Hello, my name is Michael J. Cavanaugh. Today we're going to talk about SIP trunking. What is SIP trunking? Why should you care about SIP trunking? And finally, how does SIP trunking work? So, what is SIP trunking? Well, in order to understand that, we first have to look at a PRI or non-SIP trunking world. Let's assume that we've got an office in Atlanta and one in Miami. Let's also assume that we've got a router and a LAN in Atlanta. I've got a communications manager and an IP phone in Atlanta. In Miami, I've got a router and a LAN with IP phones. And I've got some kind of WAN connection between the two today. And then I've got some kind of PSTN connection. Okay? PSTN is connected to both Atlanta and Miami with a PRI. And the PRI will give me 23 channels that will allow me to trunk to the PSTN or the telephone company as it stands. So how does this work? So in this environment, let's assume that this guy is 555-1212 is his telephone number. In Miami, let's assume that he's 555-6789. Okay? If I want to dial from this phone to that phone, I can dial 6789 from this IP phone. The call manager here will redirect me across my WAN, and we have a pure IP call between the two locations. Let's assume I've got a cell phone out here on the PSTN through my wireless carrier, and I'm going to dial 555-1212. I'm going to come to the PSTN, down this PRI, and ring this IP phone. If I want to dial Miami from my cell phone, I'll dial 555-6789. I'll come across this PSTN, down this PRI, and ring that phone. Okay, make sense? So I've got two different worlds. I've got an IP world for my enterprise, and I've got a PRI or TDM world for connections outside of my enterprise in the PSTN. That's legacy connection. So let's talk about SIP trunking and where that comes into play. In a SIP trunking world, I can do away with these PRIs and pull my connection from the PSTN into my WAN. Let's assume that my WAN is an MPLS WAN from a service provider, and they offer SIP service. What that now means is I've got SIP, which is Session Initiation Protocol, which delivers my conversation over IP. So before I was IP phone to phone, now I can be IP all the way out to the PSTN. So let's play that out as we did earlier. On my cell phone, I dial 555-1212. I come across my carrier to the PSTN. He then goes to the MPLS through SIP down my gateway to rings my phone. I no longer have this PRI. I no longer have that PRI. If I want to dial to Miami, 555-6789, I'm going to come PSTN, MPLS SIP, deliver that now to my phone. Does that make sense? So why should you care about this? Well, the most obvious reason were these PRIs right here. I no longer have two distinct networks running into my locations. So I don't have the bill for two different circuits. I've just cut that in half at minimum. Alright, so my PRI just went away. I no longer have to pay for that. I may have to increase my bandwidth a little bit to take advantage of those calls, but it's going to be nowhere near the cost of the PRI. So the initial reason I'm going to do this is cost savings. Okay? Beyond cost savings, I've also got the ability here to do things like direct trunk overflow or spilling calls from one location to another. So what do I mean by that? Let's say I lose my Atlanta office, I lose that circuit. I can, through the cloud here, redirect that call now down to Miami. So when I dial 555-1212, the cloud says, oh, I can't get there. Let's go ahead and send it over here and ring this phone. So we got a little bit of disaster recovery built in to the model. Okay. Next thing that we're going to talk about with this, in my PRI world, I said in this world I've got a PRI here. The PRI's got 23 channels. What does that mean? That means I can have up to 23 concurrent calls here. If I want 24 calls here, 25, 26, I got to buy another PRI. So I'm doubling my circuit cost. In this world here, that problem also goes away. I no longer tied to a physical circuit. I'm tied to bandwidth. So if I want more concurrent calls here, I can order more channels from my SIP provider. Assuming I've got enough bandwidth to be able to handle that, I may not need to. I can add more channels on the fly without having to add another circuit. Does that make sense? Okay. The next thing to think about today, we're talking about cost savings. We're talking about failover and DR, disaster recovery. We're also talking about scalability. Well, what about tomorrow? Well, let's talk about the way calls work in a UC environment. If I've got a phone in Atlanta and a phone in Miami, and I 4-digit dial over to this phone, let's assume that they're both video enabled. Well, what that means is, if I 4-digit dial him and we're both video enabled, we now have a video call. As an end user, I didn't have to do anything other than call that number, and boom, I have a video call. Pretty convenient. Today's world in SIP, we're really talking voice, but tomorrow's world in SIP, we're starting to take advantage of those other applications. Those other applications, one of them is video. So what if I've got another company out here that also, that also subscribes to the SIP service. They've got an IP phone, and they happen to have video as well. And let's say that I've got 20 audio channels and 10 video channels. So at that point, if I dial him and we're both video enabled, we'll have video. So we can see that we're going to start taking our data applications that we have on our data network that can interact with voice and video and things along those lines off of just our enterprise and scale those out to the cloud as well. So that's our direction of SIP in the future. Okay, so now let's look at the final question. How does SIP work? Well, earlier we talked about removing the direct connection from the PSTN. So essentially we've taken the PSTN and we've moved him to the MPLS SIP network. So what that implies is here on this SIP network, the SIP provider's got to have something that's going to terminate and change that call. Remember, here we were doing the IP to TDM. Now we're all IP. So the SIP provider now has to make that change. They have in their cloud something called a session border controller. That session border controller lives in the cloud, and he talks to your gateway, which is running in a Cisco world, software called Cube or license, Cisco Unified Border Element. So what that allows us to do is have the session border controller hand the calls to the Cube. Once the call gets to the Cube, he can then talk to the communications manager, which redirects him to the right phone. So essentially, the responsibility of changing IP to TDM is no longer on the enterprise, it's moved out to the service provider. Make sense? Thank you very much for watching, and have a great